Close your eyes for a moment and let yourself drift into the infinite expanse of the cosmos. Picture a place where time stretches endlessly, where stars are born and galaxies swirl in a dance older than imagination itself. This is the universe, a vast, mysterious canvas painted with the light of countless suns and the whispers of ancient forces. Tonight, we journey back to the very beginning, to a moment so fleeting, so profound, that it shaped everything we know. A moment when the universe, in its infancy, expanded faster than the speed of light, stretching space itself into the vastness we see today. This is the story of cosmic inflation, the rapid expansion of the early universe, and the secrets it holds about our cosmic origins. As we explore this breathtaking tale, let the soothing rhythm of the stars guide you into a state of calm, where the wonders of the cosmos lull you into a peaceful slumber. So, wherever you are, whatever time it is, let's begin this journey together into the heart of the universe's first moments. Now, let us travel even further back, to the very spark that ignited the cosmos. Imagine a single point, unimaginably small and dense, holding within it all the energy, all the matter, all the potential of the universe. In an instant, this point erupted in a burst of light and energy, a moment we now call the Big Bang. It was not an explosion in space, but rather the birth of space itself, a fiery beginning that set the stage for everything to come. In those first moments, the universe was a seething sea of energy, hotter and denser than anything we can imagine. Particles collided and merged, creating the first building blocks of matter. Space itself began to stretch and expand, carrying these particles along with it. This was the universe's first breath, a moment of creation so powerful that it echoes through the cosmos even today. But the story doesn't end there. Within a fraction of a second, something extraordinary happened. The universe didn't just expand, it exploded outward faster than the speed of light, a phenomenon known as cosmic inflation. This rapid stretching of space-time smoothed out the early universe, setting the stage for the formation of galaxies, stars, and eventually, us. Picture this, a universe so small it could fit in the palm of your hand, suddenly growing to the size of a galaxy, then a cluster of galaxies and beyond, all in the blink of an eye. This was the universe's first great leap, a moment of transformation that shaped the cosmos into the vast, beautiful expanse we see today. As we drift deeper into this story, let the enormity of this moment wash over you. The Big Bang was not just the beginning of space and time, it was the beginning of possibility, the first chapter in a story that continues to unfold with every passing second. And now, as we move forward, we'll explore how this incredible event set the stage for the mysteries of cosmic inflation and how it shaped the universe we call home. Now, let us step into the heart of one of the universe's most profound mysteries, cosmic inflation. Imagine, if you will, a balloon being blown up. At first, it's small and wrinkled, but as air fills it, the surface stretches and smooths out. Cosmic inflation is like that, but on a scale so vast it's almost impossible to comprehend. In the tiniest fraction of a second, after the Big Bang, the universe didn't just grow, it underwent an extraordinary burst of expansion, stretching space itself faster than the speed of light. Think of it as the universe taking a deep, rapid breath, inflating from something smaller than an atom to something larger than a galaxy in less time than it takes to blink. This wasn't just growth, it was a transformation, a smoothing out of the early universe's wrinkles, creating the foundation for the cosmos we see today. Without this moment of inflation, the universe might have remained a chaotic, uneven place, unable to form the stars, galaxies, and planets that fill it now. To grasp the scale of this event, picture a single grain of sand. Now imagine that grain expanding to the size of the entire Earth in an instant. That's the kind of exponential growth we're talking about. And yet, this wasn't just about size, it was about structure. The rapid stretching of space-time during inflation left behind tiny ripples, like echoes of the universe's first heartbeat. These ripples would later become the seeds for galaxies and clusters of galaxies, the building blocks of everything we know. Cosmic inflation is like the universe's first act of creation, a moment of rapid, almost magical expansion that set the stage for all that followed. It's a reminder that even in the earliest moments of existence, the universe was full of surprises, shaping itself in ways that still leave us in awe. As we continue this journey, let's explore how this incredible process unfolded and how it shaped the cosmos into the vast, interconnected web we see today. Now, let us turn our gaze to the brilliant minds who first dared to imagine the universe's rapid expansion. In the late 1970s, a young physicist named Guth was wrestling with a puzzle. He was trying to understand why the universe appeared so uniform, so smooth, on the largest scales. One night, as he sat at his desk, a spark of insight struck him. What if, he wondered, the universe had undergone a brief but extraordinary period of exponential growth in its earliest moments? This idea, which he called cosmic inflation, was like a key unlocking a door to the universe's deepest secrets. Guth's theory explained not only the smoothness of the cosmos, but also the tiny ripples that would later grow into galaxies. Around the same time, another visionary, Andrei Linde, took Guth's idea and expanded it further. Linde proposed that inflation wasn't just a one-time event, but a process that could happen repeatedly, giving rise to an infinite number of universes. His work painted a picture of a multiverse, a cosmic tapestry woven with countless threads, each representing a different universe with its own unique properties. Together, Guth and Linde transformed our understanding of the cosmos, showing us that the universe's beginnings were far more dynamic and mysterious than anyone had imagined. These pioneers didn't just propose a theory, they opened a window into the universe's infancy, revealing a story of rapid expansion and infinite possibilities. Their curiosity and courage remind us that the greatest discoveries often begin with a simple question. What if, as we drift deeper into this cosmic tale, let's carry their spirit of wonder with us, exploring the universe's hidden corners and uncovering the secrets they first glimpsed. Now, let us journey back to the very beginning, to a time so fleeting it defies imagination. In the universe's first fraction of a second, something extraordinary happened. A burst of expansion so rapid it stretched the fabric of space itself. Picture this: in less than a blink of an eye, the universe grew from a tiny speck, smaller than an atom, to something unimaginably vast. This was the era of cosmic inflation, a moment when the universe expanded faster than the speed of light, doubling in size again and again in the tiniest slivers of time. Imagine standing on the edge of a balloon as it inflates, watching the surface stretch and grow before your eyes. Now, replace the balloon with the entire universe, and you begin to grasp the scale of this event. In just 1/trillionth of a trillionth of a trillionth of a second, the universe underwent a transformation so profound that it set the stage for everything we see today. This rapid expansion smoothed out the cosmos, ironing out any irregularities and creating the uniform universe we observe on the largest scales. But how could something so vast emerge from something so small? The answer lies in the strange physics of the early universe. At these unimaginable temperatures and densities, the laws of physics, as we know them, break down and new rules take over. It was a time when energy and matter were indistinguishable, and the universe was a seething cauldron of potential. Within this chaos, inflation acted like a cosmic reset button, stretching space so quickly that it left behind the faintest ripples, tiny fluctuations that would one day grow into galaxies, stars, and planets. As we reflect on this fleeting moment, it's humbling to realize how much of our universe's story was written in that first fraction of a second. The seeds of everything, every star, every galaxy, every planet, were sown in that brief, explosive instant. And as we drift further into this cosmic tale, we'll see how these tiny ripples grew into the vast structures that fill the universe today. But for now, let's pause and marvel at the sheer audacity of it all. A universe born in a flash, expanding faster than light, and setting the stage for the wonders we now call home. Now, let us turn our attention to the delicate dance of quantum fluctuations, the subtle whispers that shape the universe as we know it. During the era of cosmic inflation, the universe was not perfectly smooth. Instead, it was filled with tiny, random variations in energy, ripples so small they were almost imperceptible. These ripples, born from the strange and unpredictable nature of quantum mechanics, were like the faintest tremors on the surface of a vast, calm ocean. Imagine standing by a still pond on a quiet morning, watching as a gentle breeze creates tiny waves that ripple across the water. These waves are barely noticeable, yet they carry the potential to grow and spread. In the same way, the quantum fluctuations during inflation were minuscule, but they held within them the seeds of the universe's future structure. As the universe expanded at an incredible rate, these tiny ripples were stretched and amplified, leaving behind a faint imprint on the fabric of space-time. These fluctuations were not random in a chaotic sense, but rather followed a delicate pattern, like the notes of a cosmic symphony. Some regions of space had slightly more energy, while others had slightly less. Over time, these differences would grow, with the denser regions pulling in more matter through gravity, eventually forming the galaxies, stars, and planets we see today. The lighter regions, on the other hand, became the vast, empty voids that stretch between these cosmic structures. What's truly remarkable is that these quantum fluctuations were so small, on the scale of 1 part in 100,000, yet they were enough to set the stage for the entire universe's large-scale structure. It's as if the universe itself was a canvas, and these tiny ripples were the first brushstrokes of a masterpiece that would take billions of years to unfold. As we reflect on this, it's awe-inspiring to think that the galaxies we see today, the stars that light up our night sky, and even the planets we call home, all trace their origins back to these faint quantum whispers. They remind us that even the smallest beginnings can lead to the grandest of outcomes, and as we continue our journey through the cosmos, we'll see how these ripples grew into the vast, interconnected web of galaxies that fills the universe today. But for now, let's take a moment to marvel at the delicate balance of chance and order that shaped everything we know. Now, let us drift deeper into the cosmos, where the very fabric of reality was stretched and reshaped by the immense forces of cosmic inflation. Picture space-time as a vast, elastic sheet, smooth and unbroken, yet capable of expanding in ways that defy our everyday understanding. During inflation, this sheet was not merely stretched, it was pulled apart at an unimaginable rate, growing exponentially larger in the blink of an eye. Imagine holding a piece of fabric between your hands, gently tugging at its edges. At first, the fabric stretches slowly, but as you pull harder, it begins to expand faster and faster, until it seems to grow without end. This is what happened to space-time during inflation. The universe, in its earliest moments, was not just expanding, it was stretching itself to become billions upon billions of times larger than it had been mere fractions of a second before. This stretching was not limited to the space between objects. It was the very fabric of space-time itself that was being pulled apart. Every point in the universe moved away from every other point, creating a vast, ever-growing expanse. It's as if the universe was a balloon, inflating so rapidly that even the tiniest distances became immense in an instant. And just as a balloon's surface grows smoother as it expands, the stretching of space-time during inflation smoothed out the universe, ironing out any irregularities and creating the remarkably uniform cosmos we observe today. What's truly astonishing is the scale of this expansion. In less than a trillionth of a second, the universe grew from a size smaller than an atom to something far larger than our entire observable universe today. This rapid stretching not only made the universe unimaginably vast, but also locked in the tiny quantum fluctuations we discussed earlier, preserving them as the seeds of future cosmic structures. As we ponder this, it's humbling to realize that the space we inhabit, the galaxies we see, and the vast distances between them all trace their origins back to this moment of cosmic stretching. The universe, once so small, became a canvas of unimaginable scale, ready to be painted with the stars, galaxies, and wonders we now observe. And as we continue our journey, we'll see how this stretching set the stage for the next chapter in the universe's story, a chapter where gravity would begin to weave its intricate patterns into the fabric of space-time. But for now, let's take a moment to marvel at the sheer scale of this cosmic expansion, a process so vast and profound that it shaped the very foundation of everything we know. As we continue our journey through the cosmos, let's pause to witness the moment when the universe's rapid expansion began to slow. Picture the early universe, still glowing with the energy of its birth, as the force driving inflation gradually weakened. Like a balloon that has been inflated to its limit, the universe reached a point where it could no longer sustain such an explosive rate of growth. This marked the end of cosmic inflation, a pivotal moment when the universe transitioned from its frenetic early expansion to a more measured pace. During this transition, the energy that had fueled inflation began to dissipate, releasing a flood of particles and radiation into the newly stretched space. This release of energy was like the universe exhaling after holding its breath, filling the cosmos with the building blocks of matter and light. The once rapid stretching of space-time slowed, and the universe entered a new phase of its evolution, one where gravity would begin to shape the structures we see today. It's fascinating to think of this moment as a cosmic turning point, a time when the universe shifted from chaos to order. The end of inflation didn't mean the universe stopped expanding. It simply meant that the rate of expansion became more gradual, allowing the forces of nature to take over and begin the work of creating galaxies, stars, and planets. This slower expansion is what we observe today, as galaxies drift apart in the vast expanse of space. As we reflect on this transition, it's almost as if the universe itself was settling down, finding its rhythm after the explosive energy of its earliest moments. The end of inflation set the stage for the next chapter in the cosmic story, where the seeds planted during that rapid expansion would grow into the intricate tapestry of the universe we know. And as we move forward, we'll explore how gravity began to weave its patterns into this cosmic fabric, shaping the destiny of everything within it. But for now, let's take a moment to appreciate this quiet shift, a moment when the universe paused, took a breath, and began its journey toward the cosmos we see today. Now, as the universe settled into its new rhythm, it left behind a faint, glowing reminder of its fiery beginnings, a cosmic whisper that still lingers in the vast expanse of space. This is the cosmic microwave background radiation, often called the afterglow of the Big Bang. Imagine it as the universe's first light, a soft, ancient glow that has traveled across billions of years to reach us. It's like the warmth of a campfire, long after the flames have died down, a gentle reminder of the incredible energy that once filled the cosmos. This faint light is everywhere, permeating every corner of the universe. It's the oldest light we can observe, a snapshot of the universe when it was just a few 100,000 years old. At that time, the universe was a dense, hot soup of particles and radiation. But as it expanded and cooled, the particles combined to form atoms, and light was finally able to travel freely. This moment, when the universe became transparent, marked the birth of the cosmic microwave background, a glow that has been stretching and fading ever since. Picture this ancient light as a cosmic lullaby, a soothing hum that fills the void of space. It's not just a relic of the past, it's a map of the early universe, carrying with it the faint imprints of the tiny quantum fluctuations that would one day grow into galaxies and stars. These ripples in the fabric of space-time, frozen in time, tell the story of how the universe began to take shape. As you drift into the quiet of the night, let this ancient light guide your thoughts. It's a reminder that even in the vastness of the cosmos, there's a connection to the very beginning of everything. The cosmic microwave background is more than just light. It's a story, a memory, and a testament to the universe's incredible journey. And as we continue to explore its secrets, we uncover not just the history of the cosmos, but also the threads that bind us to its grand tapestry. Now, let's turn our attention to the clues that scientists have uncovered, the evidence that points to the reality of cosmic inflation. One of the most compelling pieces of this cosmic puzzle lies in the very light we've been discussing, the cosmic microwave background. This ancient glow, as it turns out, is not just a relic of the past. It's a treasure trove of information about the universe's earliest moments. When scientists first mapped the cosmic microwave background, they were struck by its remarkable uniformity. No matter where they looked, the temperature of this faint light was almost exactly the same, varying by less than 1 part in 100,000. This near-perfect uniformity is a mystery that defies explanation without cosmic inflation. Think of it like this. If you stirred a pot of soup and then left it to cool, you'd expect the temperature to be the same throughout. But in the universe's case, regions that are now billions of light years apart were once close enough to exchange heat and reach equilibrium. Without inflation, there simply wouldn't have been enough time for this to happen. Inflation, with its rapid expansion, provides the answer, stretching these regions apart while preserving their uniformity. But the story doesn't end there. Hidden within this uniform glow are tiny fluctuations, ripples in the temperature that correspond to the seeds of cosmic structure. These fluctuations, imprinted during inflation, are the fingerprints of quantum mechanics on a cosmic scale. They tell us that even in the earliest moments of the universe, there was a delicate dance of energy and space-time, a dance that would eventually give rise to galaxies, stars, and planets. Another piece of evidence comes from the large-scale structure of the universe itself. The distribution of galaxies and galaxy clusters across the cosmos matches the predictions made by inflation theory. These structures, vast and intricate, trace their origins back to those tiny quantum fluctuations, stretched and amplified by inflation. It's as if the universe left behind a blueprint, and scientists are now deciphering it, piece by piece. As we piece together these clues, we begin to see the bigger picture, the uniformity of the cosmic microwave background, the patterns in the distribution of galaxies, and the echoes of quantum fluctuations all point to one conclusion. Cosmic inflation is not just a theory, it's a key to understanding the universe's origins. And as we continue to explore these mysteries, we uncover not just the story of the cosmos, but also the profound connections that bind us to its unfolding narrative. As we delve deeper into the mysteries of cosmic inflation, a fascinating question arises. Could our universe be just one of many? This is where the multiverse hypothesis comes into play, a concept that stretches the imagination and invites us to ponder the existence of infinite worlds beyond our own. Picture, if you will, a vast cosmic ocean, where each bubble represents a separate universe, each with its own unique set of physical laws and properties. These bubbles, born from the rapid expansion of space-time during inflation, could exist alongside one another, forever out of reach yet connected by the same cosmic fabric. The idea of a multiverse isn't just science fiction, it's a natural extension of inflation theory. If inflation occurred once, why couldn't it happen again and again in different regions of space-time? Each burst of inflation could give rise to a new universe, each one a self-contained realm with its own history, stars, and perhaps even life. Some of these universes might be strikingly similar to ours, while others could be wildly different, governed by laws of physics we can scarcely imagine. What's truly captivating about the multiverse hypothesis is how it challenges our understanding of reality. It suggests that our universe, vast as it is, might be just one thread in an infinite cosmic tapestry. Imagine standing on the shore of this cosmic ocean, gazing out at the endless horizon, knowing that beyond it lie worlds beyond counting, each one a story waiting to be told. It's a thought that fills the mind with wonder and curiosity, inviting us to explore the boundaries of what we know and what we might one day discover. While the multiverse remains a theoretical concept, it's a powerful reminder of the universe's boundless possibilities. It encourages us to think beyond the limits of our own experience and consider the extraordinary diversity that might exist in the grand scheme of existence. And as we continue to unravel the secrets of cosmic inflation, we may find that the multiverse is not just a dream, but a key to understanding the true nature of reality itself. Now, as we turn our gaze to the present, we encounter another profound mystery shaping the cosmos: dark energy. This invisible force, though elusive and enigmatic, plays a crucial role in the ongoing expansion of our universe. Imagine the universe as a vast, ever-growing tapestry, with dark energy acting as the unseen hand, gently pulling at its edges, causing it to stretch and expand over time. Unlike gravity, which pulls matter together, dark energy works in the opposite direction, pushing galaxies farther apart and accelerating the universe's growth. What makes dark energy so intriguing is that it remains one of the greatest puzzles in modern science. We cannot see it, touch it, or directly measure it, yet its effects are undeniable. Observations of distant galaxies reveal that they are moving away from us faster than expected, a phenomenon that can only be explained by the presence of this mysterious force. It's as if the universe itself is infused with an invisible energy, quietly shaping its destiny. Scientists believe that dark energy makes up about 68% of the universe's total energy content, dwarfing even the influence of dark matter and ordinary matter. Yet, despite its dominance, we know very little about what it truly is. Some theories suggest it could be a property of space itself, a kind of cosmic background energy that permeates the universe. Others propose it might be connected to a new, undiscovered field or particle, waiting to be uncovered by future discoveries. As we ponder the nature of dark energy, we are reminded of how much remains unknown about the cosmos. It's a humbling thought, one that invites us to marvel at the universe's complexity and the endless questions it presents. And while dark energy may remain a mystery for now, its existence reminds us that the story of the universe is still being written, with each discovery bringing us closer to understanding the forces that shape our reality. With this in mind, let's explore how the universe's hidden dimensions might hold further clues to these cosmic mysteries. As we venture deeper into the mysteries of the cosmos, let us now turn our attention to a concept that stretches the boundaries of our imagination: the universe's hidden dimensions. Picture space-time not as the familiar three-dimensional fabric we know, but as something far more intricate, woven with extra dimensions that lie just beyond our perception. These unseen layers, suggested by theories of cosmic inflation, could hold the key to understanding the universe's most profound secrets. Imagine space-time as a vast, multidimensional tapestry, where every thread represents a dimension beyond the ones we experience. While we move through length, width, and height, these hidden dimensions remain curled up, too tiny to detect with our current tools. Yet, they might play a crucial role in shaping the forces and particles that make up our reality. It's as if the universe is a grand symphony, with these extra dimensions adding harmonies we have yet to fully hear. Some theories propose that these hidden dimensions could explain why gravity appears so much weaker than the other fundamental forces. Perhaps gravity, unlike light or electromagnetism, is not confined to our familiar three dimensions, but spills into these unseen realms, diluting its strength. This idea opens up a world of possibilities, suggesting that the universe is far more complex and interconnected than we once thought. As we ponder these hidden dimensions, we are reminded of how much of the cosmos remains beyond our grasp. They invite us to dream of realms where the laws of physics might take on entirely new forms, where space and time could behave in ways we can scarcely imagine. It's a humbling thought, one that challenges us to expand our understanding and embrace the unknown. With this in mind, let us now explore how these hidden dimensions might connect to the cosmic symphony that began with inflation, shaping the universe in ways we are only beginning to uncover. Now, let us step into the grand cosmic symphony, where the early universe unfolds like a breathtaking orchestral performance. Imagine the moment of cosmic inflation as the opening crescendo, a powerful surge of energy that set the stage for everything to come. Just as a symphony begins with a single, resonant note, the universe burst into existence with a single, explosive event, the Big Bang. But it was cosmic inflation that truly gave the universe its rhythm, its structure, and its harmony. In those first fleeting moments, space-time expanded faster than the speed of light, stretching the fabric of reality like a conductor's baton sweeping across an orchestra. This rapid expansion was not chaotic, but precise, like the intricate arrangement of musical notes in a symphony. Each quantum fluctuation, each tiny ripple in the early universe, became a note in this cosmic composition, destined to grow into the galaxies, stars, and planets we see today. Think of the universe as a vast, ever-evolving piece of music. The forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces are the instruments, each playing its part in the cosmic score. Gravity, the deep bass, pulls matter together, while electromagnetism, the shimmering strings, binds atoms and molecules. The strong and weak nuclear forces, like the percussion section, drive the reactions that power stars and shape the elements. As the symphony progresses, the universe cools and settles, much like a musical piece, transitioning from a dramatic opening to a softer, more melodic movement. The first stars ignite, their light like the gentle notes of a piano, illuminating the darkness. Galaxies form, their swirling arms dancing like the crescendos and decrescendos of a violin solo. And through it all, the cosmic microwave background hums softly in the background, a faint echo of the universe's earliest moments. This cosmic symphony is not just a metaphor, it's a reminder of the elegance and order that underlies the universe's vast complexity. Just as a symphony is composed of countless individual notes, the universe is built from countless particles, forces, and interactions, all working together in perfect harmony. And as we listen to this cosmic music, we are reminded of our place within it, a small but integral part of a grand, unfolding masterpiece. With this symphony in mind, let us now turn to the seeds of galaxies, exploring how those early quantum fluctuations grew into the vast structures that fill our universe today. Now, let us trace the journey of those tiny ripples in the early universe, the quantum fluctuations that would one day become the seeds of galaxies. Picture these fluctuations as delicate threads woven into the fabric of space-time, each one a whisper of potential waiting to unfold. During the era of cosmic inflation, these threads were stretched and amplified, growing from microscopic imperfections into the foundations of cosmic structure. As the universe expanded, gravity began to play its part, gently tugging at these ripples, pulling matter together in a slow, cosmic dance. Imagine these fluctuations as seeds scattered across a vast, fertile field. Over billions of years, gravity nurtured these seeds, allowing them to grow into dense pockets of matter. These pockets became the nurseries for the first stars and galaxies, their light piercing the darkness of the early universe. The process was gradual, almost imperceptible at first, yet as time passed, these tiny seeds blossomed into immense structures, their gravitational pull drawing in more and more matter. Galaxies began to form, their swirling arms filled with stars, planets, and the building blocks of life. Each galaxy, a testament to the power of those initial fluctuations, carries within it the echoes of the universe's earliest moments. Think of it as a cosmic tapestry, where every thread, every ripple, contributes to the grand design. The galaxies we see today, with their dazzling arrays of stars and swirling clouds of gas, are the result of this intricate process. They are the legacy of those first quantum whispers, a reminder of how even the smallest beginnings can lead to the most extraordinary outcomes. As we gaze at the night sky, we are witnessing the culmination of this cosmic transformation. Each galaxy, each star, is a chapter in the story of the universe, a story that began with the tiniest of ripples and continues to unfold in ways that inspire awe and wonder. And so, as we ponder the seeds of galaxies, we are reminded of the profound connection between the smallest beginnings and the vast, beautiful cosmos we call home. As we continue our journey through the cosmos, let us now step into a moment of profound transformation, a time when the universe itself began to shine. Picture this: after hundreds of millions of years of darkness, the universe finally became transparent, allowing light to break free and travel across the vast expanse of space. This was the dawn of the universe's first light, a moment that illuminated the cosmos and set the stage for everything we see today. Imagine the universe as a dense, foggy cloud, filled with particles that scattered light in every direction. During this early era, photons, tiny particles of light, were constantly absorbed and re-emitted, trapped in a cosmic dance with matter. But as the universe expanded and cooled, electrons and protons began to combine, forming neutral hydrogen atoms. This process, known as recombination, cleared the fog, allowing light to travel freely for the first time. It was as if a cosmic curtain had been lifted, revealing a universe bathed in a warm, golden glow. This first light, now known as the cosmic microwave background, is the oldest light we can observe. It carries with it the echoes of the universe's infancy, a snapshot of a time when everything was simpler, smaller, and yet filled with infinite potential. Think of it as the universe's first photograph, a faint but enduring reminder of its earliest moments. As this light began to travel, it carried with it the story of the cosmos, a story written in the language of photons. Over billions of years, this light has stretched and shifted, its once vivid glow fading into the faint microwave radiation we detect today. Yet even now, it continues to illuminate our understanding of the universe, offering clues about its origins and evolution. This moment of transparency was not just a turning point for the universe, it was a turning point for us. Without it, the stars and galaxies we marvel at today would remain hidden, their light forever trapped in the cosmic fog. But thanks to this ancient glow, we can peer back in time, tracing the universe's journey from its fiery beginnings to the vast, luminous tapestry we see today. As we reflect on the universe's first light, we are reminded of the beauty and wonder of discovery. It is a light that connects us to the cosmos, a beacon that guides our understanding and fuels our curiosity. And so, as we gaze into the night sky, we are not just observers, we are part of a story that began with a single, radiant moment, a moment that continues to shine across the ages. Now, let us turn our gaze to the intricate tapestry of the cosmos, where the seeds of inflation have woven a vast and interconnected network known as the cosmic web. Picture this: billions of galaxies, each a glowing island of stars, connected by invisible threads of dark matter, stretching across the universe like a delicate spider's web. This is the cosmic web, the grand architecture of the universe, a structure born from the tiny ripples of quantum fluctuations during inflation. Imagine the universe as a canvas, and inflation as the brush that painted the first strokes. Those faint ripples, once smaller than an atom, grew over billions of years, pulled by gravity into a sprawling network of filaments and voids. The densest regions became the galaxies and clusters we see today, while the emptier spaces formed the vast cosmic voids, stretching for millions of light years. Together, they create a pattern that resembles a web, a structure so vast it defies comprehension. This cosmic web is not just a static image, it is alive with motion and energy. Galaxies flow along the filaments, drawn together by gravity's invisible hand, while dark matter, the unseen scaffolding of the universe, holds it all together. It is a dance of matter and energy, a symphony of forces that has been playing out since the dawn of time. And just as a spider's web catches the morning dew, the cosmic web captures the light of countless stars, illuminating the universe in a breathtaking display of interconnected beauty. As we trace the threads of this cosmic web, we begin to see how everything in the universe is connected. The galaxies we observe today, the stars that light our night sky, even the atoms that make up our bodies, all of it can be traced back to those first moments of inflation. The cosmic web is not just a structure, it is a story, a narrative of how the universe grew from a tiny seed into the vast, intricate network we see today. And so, as we contemplate the cosmic web, we are reminded of the unity of all things. It is a reminder that we are not separate from the cosmos, but a part of it, woven into its fabric by the same forces that shape the stars and galaxies. The cosmic web is a testament to the beauty of connection, a reminder that even in the vastness of space, everything is intertwined. And as we gaze into the night sky, we are not just observers, we are threads in this grand cosmic tapestry, forever connected to the universe's endless story. Now, let us journey deeper into the mysteries of the early universe, where the faint whispers of cosmic inflation still linger. These whispers, known as the echoes of inflation, are etched into the cosmic microwave background, the oldest light in the universe. Imagine this light as a cosmic photograph, capturing the universe just moments after its birth, a snapshot frozen in time. Scientists, like cosmic detectives, study this ancient light, searching for clues that reveal the secrets of inflation. The cosmic microwave background is not just a uniform glow, it is a tapestry of tiny temperature variations, patterns that tell the story of the universe's earliest moments. These patterns are the fingerprints of quantum fluctuations, the same ripples that grew into the cosmic web we see today. By mapping these variations, scientists can trace the echoes of inflation, uncovering how the universe expanded faster than the speed of light in its first fraction of a second. Think of it as listening to a faint, distant melody. The cosmic microwave background is like a cosmic symphony, with each note representing a fluctuation in the early universe. Scientists use powerful telescopes and satellites to tune in to this symphony, analyzing its harmonies and dissonances to piece together the story of inflation. It is a painstaking process, requiring precision and patience, but the rewards are profound. Each discovery brings us closer to understanding how the universe began and how it evolved into the vast, intricate cosmos we inhabit today. This search for echoes is not just a scientific endeavor, it is a journey of curiosity and wonder. It reminds us that the universe is full of mysteries waiting to be uncovered, and that even the faintest whispers can reveal profound truths. As we drift into the realm of sleep, let us imagine ourselves as cosmic detectives, following the trail of these ancient echoes, unraveling the story of the universe's birth. And as we do, we are reminded that the universe is not just a place of stars and galaxies, but a living, breathing story, one that we are all a part of. As we turn our gaze to the present, the story of the universe unfolds in a way that is both awe-inspiring and humbling. The expansion that began with cosmic inflation billions of years ago continues even now, carrying galaxies farther and farther apart like leaves drifting on a vast cosmic river. This ongoing expansion is not just a relic of the past, it is a living, breathing process that shapes the universe we see today. Picture the universe as an ever-growing tapestry, woven with threads of galaxies, stars, and planets. Each thread moves steadily away from the others, not because they are being pushed, but because the fabric of space itself is stretching. This stretching is gentle yet relentless, a quiet force that has been at work since the dawn of time. Galaxies that were once close neighbors are now separated by unimaginable distances, their light taking billions of years to reach us. This expansion is not something we can see with our eyes, but its effects are everywhere. When astronomers look at distant galaxies, they notice something remarkable. The light from these galaxies is stretched, shifting toward the red end of the spectrum. This phenomenon, known as redshift, is a telltale sign of the universe's expansion. It is as if the universe itself is whispering to us, revealing its secrets through the language of light. And yet, this expansion is not uniform. While galaxies move apart on the largest scales, gravity still holds sway in local regions, pulling galaxies together into clusters and superclusters. These cosmic gatherings are like islands in an ever-widening sea, bound by the invisible threads of gravity, even as the space between them grows. What drives this expansion? The answer lies in a mysterious force known as dark energy, an unseen energy that permeates the universe and accelerates its growth. While we cannot see or touch dark energy, its effects are undeniable, shaping the fate of the cosmos in ways we are only beginning to understand. As we ponder this ongoing expansion, we are reminded of the universe's boundless nature. It is a place of constant change, where the past, present, and future are intertwined in a delicate dance. And as we drift into the realm of sleep, let us imagine ourselves floating on this cosmic river, carried along by the gentle currents of an ever-expanding universe, a universe that continues to grow, evolve, and inspire wonder. As we drift deeper into the mysteries of the cosmos, let us turn our thoughts to the ultimate fate of the universe. What lies ahead for this vast, ever-expanding tapestry of stars, galaxies, and space itself? Scientists have proposed several possibilities, each as fascinating as it is profound, inviting us to reflect on the grand destiny of all that exists. One such possibility is known as the Big Freeze. Imagine a universe that continues to expand, its galaxies growing ever more distant, its stars burning out one by one. Over trillions of years, the universe would grow colder and darker, its energy spread so thin that even the formation of new stars becomes impossible. In this scenario, the cosmos would gradually fade into a quiet, frozen expanse, a silent and eternal night where even time itself seems to slow to a halt. It is a gentle yet somber vision, a reminder of the impermanence that underlies even the most enduring structures of the universe. But the Big Freeze is not the only possibility. Another theory, known as the Big Rip, paints a more dramatic picture. Here, the mysterious force of dark energy grows stronger over time, accelerating the expansion of the universe to unimaginable speeds. Eventually, this force could become so powerful that it tears apart galaxies, stars, and even the fabric of space-time itself. In this scenario, the universe would end not with a whisper, but with a cosmic crescendo, as everything is pulled apart in a final, explosive moment. It is a fate that speaks to the raw, untamed power of the forces that shape our reality. Between these two extremes lies the Big Crunch, a theory that suggests the universe might one day stop expanding and begin to collapse back in on itself. Galaxies would draw closer together, space would contract, and the universe would grow denser and hotter until it reaches a single, fiery point. Some imagine this as a cosmic rebirth, a moment when the universe might begin anew, cycling through expansion and contraction in an endless dance of creation and destruction. As we ponder these possibilities, we are reminded of the delicate balance that governs the cosmos. The fate of the universe is shaped by forces we are only beginning to understand, forces that hint at the profound interconnectedness of all things. Whether the universe ends in a freeze, a rip, or a crunch, these theories invite us to reflect on the beauty and fragility of existence and the endless mysteries that lie beyond our understanding. And so, as we prepare to close our eyes and drift into sleep, let us carry with us these visions of the cosmos, not as distant or abstract ideas, but as reminders of the wonder that surrounds us. The universe, in all its vastness, is a story still being written, a story in which we, too, play a small but meaningful part. Let us dream of its possibilities and find peace in the knowledge that, no matter what the future holds, the universe will always be a place of awe, mystery, and infinite potential. Now, as we turn our gaze to the beauty of the cosmos, let us pause and marvel at the sheer grandeur of the universe. Picture, for a moment, the countless stars scattered across the night sky, each one a distant sun, burning with its own light and energy. These stars are not just points of light, they are the building blocks of galaxies, vast islands of matter and energy that stretch across unimaginable distances. The Milky Way, our own galaxy, is home to hundreds of billions of stars, each with its own story, its own mysteries waiting to be uncovered. Beyond our galaxy lies an even greater expanse, a universe filled with billions of other galaxies, each one a swirling tapestry of stars, gas, and dust. Some galaxies are spiral-shaped, their arms curling gracefully through space, while others are elliptical, smooth, and serene. And then there are the irregular galaxies, wild and untamed, their shapes defying easy description. Together, these galaxies form a cosmic web, a vast network of light and matter that stretches across the universe, connecting everything in a delicate balance. But the beauty of the cosmos is not just in its scale, it is also in its details. Consider the delicate dance of planets orbiting their stars, the intricate patterns of nebulae where new stars are born, and the quiet majesty of black holes, whose immense gravity bends light and time itself. Every corner of the universe holds wonders, from the smallest particles to the largest structures, each one a testament to the complexity and elegance of the natural world. And then there is the light, the ancient light that has traveled across billions of years to reach us. This light carries with it the stories of the universe's past, from the fiery birth of stars to the quiet glow of galaxies fading into the distance. When we look up at the night sky, we are not just seeing points of light, we are witnessing the history of the cosmos itself, a history written in the language of light and time. As we reflect on this beauty, let us also remember our place within it. We are part of this vast, interconnected universe, born from the same stars and shaped by the same forces. The atoms in our bodies were forged in the hearts of ancient stars, and the energy that flows through us is a part of the same cosmic dance that moves the galaxies. In this way, the universe is not just something we observe, it is something we are a part of, a story in which we play a small but meaningful role. So, as we prepare to close our eyes and drift into sleep, let us carry with us the beauty of the cosmos, not as a distant or abstract idea, but as a source of wonder and inspiration. The universe, in all its vastness and complexity, is a reminder of the infinite possibilities that lie before us, a reminder that we are part of something greater than ourselves. Let us dream of its beauty and find peace in the knowledge that, no matter where we are, the cosmos is always with us, a silent companion in the journey of life. As we drift deeper into the story of the cosmos, let us now turn our attention to the quiet yet powerful force that has shaped the universe as we know it, gravity. Imagine, if you will, the early universe, still echoing with the aftermath of cosmic inflation. The stage is set, the particles are scattered, and the seeds of structure are sown. But it is gravity that steps in, like a cosmic choreographer, to bring order to the chaos. In those first moments after inflation, the universe was a sea of particles, swirling and drifting in the vast expanse of space. Gravity, though the weakest of the fundamental forces, began its slow and steady work. It reached out across the cosmos, pulling particles together, gathering them into clumps and clusters. These clumps grew denser and denser, their gravitational pull growing stronger with each passing moment. Over time, they became the building blocks of stars and galaxies, the very foundations of the universe we see today. Picture this cosmic dance, clouds of gas and dust, drawn together by gravity, collapsing under their own weight. As they collapse, they heat up, igniting the fires of nuclear fusion. And so, the first stars are born, their light piercing the darkness of the early universe. These stars, in turn, gather into galaxies, vast collections of billions of stars, each one a tiny island in the cosmic ocean. Gravity binds them together, holding them in place as they spin and swirl through space. But gravity's role does not end there. It shapes the very fabric of the universe, bending space and time, creating the intricate web of galaxies we see today. It pulls galaxies together into clusters and clusters into superclusters, forming the largest structures in the cosmos. And yet, for all its power, gravity works slowly, patiently, over billions of years, weaving the tapestry of the universe one thread at a time. As we reflect on this cosmic dance, let us marvel at the elegance of gravity's work. It is a force that is both gentle and relentless, shaping the universe with a quiet persistence. Without gravity, the universe would be a formless void, a sea of particles drifting aimlessly through space. But with gravity, the universe becomes a place of structure and beauty, a place where stars are born, galaxies form, and life itself becomes possible. So, as we close our eyes and let the story of the cosmos carry us away, let us remember the role of gravity in this grand cosmic dance. It is a reminder that even the smallest forces can have the greatest impact, shaping the universe in ways that are both profound and beautiful. And as we drift into sleep, let us feel the gentle pull of gravity, not just as a force of nature, but as a part of the story that connects us all. As we journey further into the story of the cosmos, let us now turn our gaze to a time when the universe was young, and the first stars and galaxies began to emerge from the darkness. Picture this, the early universe, still cooling from the fiery aftermath of the Big Bang, is a vast, shadowy expanse. But within this darkness, something extraordinary is happening. Tiny pockets of gas, left over from the cosmic inflation, begin to stir. These pockets, rich with hydrogen and helium, are the seeds of the first stars. Gravity, ever the patient architect, continues its work, pulling these clouds of gas closer and closer together. As they collapse, the pressure and heat at their cores grow immense. Imagine the moment when the temperature reaches a critical point and nuclear fusion ignites. A spark of light bursts forth, piercing the darkness. The first stars are born, their brilliance illuminating the cosmos for the very first time. These stars, massive and hot, burn fiercely, their light traveling across the universe, a beacon in the void. But the story does not end there. These first stars, though magnificent, are not destined to shine forever. After millions of years, they exhaust their fuel and explode in spectacular supernova, scattering their elements across space. These elements, forged in the hearts of stars, become the building blocks for new stars, planets, and even life itself. It is a cycle of creation and destruction, a cosmic dance that continues to this day. As these stars live and die, they begin to gather together, drawn by gravity into vast, swirling collections. These are the first galaxies, islands of light in the dark sea of space. Each galaxy is a tapestry of stars, gas, and dust, spinning and swirling in a delicate balance. Picture the Milky Way, our own galaxy, as it might have looked in its infancy, a glowing spiral, its arms reaching out into the void, filled with the light of countless stars. The formation of these first stars and galaxies marks a turning point in the history of the universe. No longer is it a formless expanse of gas and darkness. Now it is a place of light and structure, a canvas upon which the story of the cosmos will continue to unfold. And as we reflect on this era, let us marvel at the beauty and complexity of the universe, a place where even the smallest particles can come together to create something truly extraordinary. So, as we close our eyes and let the story of the cosmos carry us away, let us imagine the first stars, their light piercing the darkness, and the first galaxies, their arms reaching out into the void. It is a reminder that even in the vastness of space, there is a delicate balance, a harmony that connects us all. And as we drift into sleep, let us feel the warmth of those first stars, their light still shining across the ages, a testament to the beauty and wonder of the universe. Now, let us step back and trace the grand arc of the universe's story, from its explosive beginnings to the present day. Picture this timeline as a vast, flowing river, carrying us through the ages, each moment a ripple in the current of cosmic history. It all begins with the Big Bang, that singular moment when space and time burst into existence, setting the stage for everything that would follow. In those first fleeting instants, cosmic inflation stretched the universe, expanding it faster than the speed of light, smoothing out its fabric and planting the seeds of all future structure. As the universe cooled, the first particles began to form, and the fog of energy gave way to the first atoms. Hydrogen and helium, the simplest elements, filled the cosmos, creating a vast, dark sea. But within this darkness, gravity began its quiet work, pulling matter together into clumps that would eventually ignite as the first stars. These stars, born from the primordial gas, lit up the universe, their light piercing the darkness for the very first time. They lived fast and died young, their explosive deaths scattering heavier elements into space, enriching the cosmos with the building blocks of planets, life, and everything we know today. Over billions of years, galaxies began to form, swirling collections of stars, gas, and dust, each one a tiny island in the vast ocean of space. Our own Milky Way took shape, its spiral arms spinning gracefully, a cosmic dance that continues to this day. Within these galaxies, new stars were born, and around them, planets coalesced, including our own Earth. And here, on this tiny blue dot, life emerged, a spark of consciousness in the vastness of the universe. As we move closer to the present, we see the universe continuing to expand, galaxies drifting apart like leaves on a widening river. Dark energy, a mysterious force, now drives this expansion, pushing the cosmos ever outward. And yet, even as the universe grows larger, it remains connected, a tapestry woven from the threads of its earliest moments. The light from those first stars still travels through space, reaching us as a faint whisper from the past, a reminder of where it all began. So, as we reflect on this cosmic timeline, let us marvel at the journey of the universe, from its fiery birth to the delicate balance of today. It is a story of creation and transformation, of light emerging from darkness, and of the endless dance of matter and energy. And as we drift into sleep, let us carry this story with us, a reminder of our place in the vast, unfolding tapestry of the cosmos. As we journey deeper into the story of the cosmos, we find ourselves standing at the edge of the unknown, gazing into the mysteries that still shroud the early universe. Cosmic inflation, though a cornerstone of our understanding, leaves us with questions that linger like whispers in the dark. What exactly triggered this rapid expansion? What lay beyond the boundaries of the observable universe, stretching far beyond what our telescopes can see? These are the hidden secrets that scientists continue to unravel, each discovery peeling back another layer of the cosmic veil. Consider, for a moment, the nature of the quantum fluctuations that seeded the universe's structure. These tiny ripples, born in the chaos of inflation, grew into the galaxies and stars we see today. Yet, their origins remain a puzzle. How did these fluctuations arise, and what forces shaped their delicate patterns? The answers may lie in the realm of quantum physics, where the rules of the very small intersect with the vastness of the cosmos. It's a dance of particles and probabilities, a cosmic ballet that we are only beginning to understand. And then there is the question of what came before the Big Bang. Was there a before, or did time itself begin in that explosive moment? Some theories suggest that our universe is just one of many, part of a multiverse, where countless other realities exist alongside our own. If true, what might these other universes look like? Are they similar to ours, or do they follow entirely different laws of physics? The possibilities are as endless as the cosmos itself, inviting us to dream of worlds beyond our imagination. Even the force that drives the universe's expansion today, dark energy, remains an enigma. What is it, and why does it behave the way it does? Is it a constant force, or could it change over time, altering the fate of the universe in ways we cannot yet predict? These questions remind us that the cosmos is not a static place, but a dynamic, ever-changing tapestry, woven with threads of mystery and wonder. As we ponder these hidden secrets, let us embrace the beauty of the unknown. The universe, in all its vastness, is a story still being written, with chapters yet to be discovered. And as we drift into sleep, let these mysteries linger in our thoughts, a reminder that the cosmos is not just a place of answers, but a realm of endless questions, waiting for curious minds to explore. Now, let us turn our gaze closer to home, to the universe we inhabit today, and explore how the echoes of cosmic inflation have shaped the very fabric of our existence. The story of the cosmos is not just a tale of distant stars and ancient light. It is also the story of us, of the world we know, and the life that thrives within it. Every atom in our bodies, every star in the night sky, and every galaxy spinning in the vast expanse can trace its origins back to those first moments of rapid expansion. Think of the universe as a grand tapestry, woven together by the threads of cosmic inflation. Those tiny quantum fluctuations, the ripples in space-time that emerge during inflation, grew over billions of years to become the seeds of galaxies, stars, and planets. Without these fluctuations, the universe would have been a featureless void, devoid of the structures that make life possible. It was these delicate patterns, imprinted in the early universe, that set the stage for the formation of everything we see around us. Consider the elements that make up our world: carbon, oxygen, iron, and more. These were forged in the hearts of stars, born from the gravitational collapse of matter that itself originated in the aftermath of inflation. The very air we breathe, the ground beneath our feet, and the light that warms our planet are all part of this cosmic legacy. In a very real sense, we are made of stardust, the remnants of a universe that began its journey in a burst of unimaginable energy. But the connection goes even deeper. The laws of physics that govern our universe, gravity, electromagnetism, and the forces that hold atoms together, were shaped during those early moments of inflation. The balance of these forces is so precise that even the slightest change would have made life, as we know it, impossible. It is as if the universe was fine-tuned, not by chance, but by the intricate dance of cosmic inflation and the forces it unleashed. As we reflect on this profound connection, let us also consider the role of curiosity and discovery in our lives. The same forces that shape the cosmos also drive us to explore, to ask questions, and to seek understanding. In learning about the universe, we learn about ourselves, about our place in the grand scheme of things. The story of cosmic inflation is not just a scientific narrative. It is a reminder of our shared origins and the boundless potential of the human spirit to uncover the mysteries of existence. So, as you drift into sleep tonight, let this thought linger in your mind. The universe is not just out there, distant and unreachable. It is here, within you, a part of your very being. And as you rest, know that you are connected to a story that began billions of years ago, a story that continues to unfold with every passing moment. The cosmos is not just a place, it is a journey, and we are all travelers on this incredible path. As we continue our journey through the cosmos, let us take a moment to marvel at the human spirit's unyielding quest to understand the universe. From the earliest myths told under starlit skies to the cutting-edge discoveries of modern science, our desire to explore and comprehend the mysteries of existence has been a constant thread woven through the fabric of history. This is not just a story of science, it is a story of curiosity, imagination, and the relentless pursuit of knowledge. Think of the ancient civilizations that gazed at the heavens, weaving tales of gods and heroes to explain the movements of the stars. These stories, though born of imagination, were humanity's first steps toward understanding the cosmos. They remind us that the urge to explore and explain is as old as humanity itself. Over time, these myths gave way to observation and reason, as thinkers like Galileo and Newton began to unravel the laws that govern the universe. Each discovery, each leap forward, built upon the work of those who came before, creating a legacy of knowledge that continues to grow. Today, we stand on the shoulders of giants, armed with tools and technologies that allow us to peer deeper into the cosmos than ever before. Telescopes capture the faintest light from distant galaxies, while particle accelerators recreate the conditions of the early universe. Yet, even as we uncover new truths, the universe remains full of mysteries waiting to be solved. The search for answers is not just a scientific endeavor, it is a testament to our shared humanity, a reminder that we are all part of a grand, ongoing story. This journey of discovery is not confined to laboratories or observatories. It lives in the questions we ask, the wonder we feel when we look up at the night sky, and the stories we tell to make sense of the world around us. It is in the child who wonders why the stars shine, the student who dreams of exploring distant planets, and the scientist who dedicates their life to unraveling the secrets of the cosmos. Each of us, in our own way, contributes to this collective quest for understanding. As we reflect on this journey, let us also celebrate the beauty of the unknown. The universe is vast and complex, filled with questions that may never be fully answered. Yet, it is precisely this mystery that drives us forward, inspiring us to explore, to imagine, and to dream. In seeking to understand the cosmos, we come to understand ourselves, our place in the universe, and the boundless potential of the human spirit. So, as you drift into sleep tonight, let the wonder of discovery fill your thoughts. Remember that you are part of a story that spans millennia, a story of curiosity, courage, and the unending quest for knowledge. The universe is not just a place to be studied, it is an invitation to explore, to wonder, and to dream. And as you rest, know that the journey continues, with each new discovery bringing us closer to the stars. Now, let us turn our gaze to the infinite possibilities that the universe holds. Imagine, for a moment, a canvas so vast that it stretches beyond the limits of our imagination, dotted with galaxies, stars, and worlds yet to be discovered. This is the universe, a place where the unknown is not a void, but a treasure trove of endless potential. Every corner of the cosmos whispers secrets, every star a story waiting to be told, and every galaxy a mystery waiting to be unraveled. Consider the distant galaxies, swirling in the darkness like cosmic dancers. Each one is a universe unto itself, with billions of stars and planets, some perhaps harboring life in forms we cannot yet conceive. What wonders might exist on those distant worlds? What stories might their skies tell? The universe does not limit itself to what we know or understand. It is a realm of infinite variety, where the rules of physics bend and stretch, creating phenomena that challenge our very notions of reality. Think of the unknown phenomena that lie beyond our current understanding. Dark energy, dark matter, and the enigmatic forces that shape the cosmos are just the beginning. There may be dimensions we cannot perceive, realms of existence that defy our comprehension, and laws of nature that operate in ways we have yet to imagine. The universe is not a static place. It is a dynamic, ever-evolving tapestry of possibilities, each thread woven with the potential for discovery. And then there are the questions that linger in the quiet spaces between the stars. Are we alone in the universe, or is life a common thread woven through the fabric of existence? Could there be civilizations far more advanced than our own, gazing at the same stars and pondering the same mysteries? The universe does not provide easy answers, but it invites us to dream, to wonder, and to explore. It reminds us that the journey of discovery is not just about finding answers. It is about embracing the infinite possibilities that lie before us. As you drift into sleep tonight, let your mind wander through the vast expanse of the cosmos. Picture the galaxies spinning in the darkness, the stars shining like beacons of hope, and the endless possibilities that await us. The universe is not just a place, it is a promise, a reminder that there is always more to discover, more to learn, and more to dream. And as you rest, know that the infinite possibilities of the cosmos are not just out there, they are within you, waiting to be explored. As we bring our journey through the cosmos to a close, let us pause and reflect on the incredible story that continues to unfold around us. The universe is not a static entity. It is a living, breathing tapestry, constantly evolving and revealing new wonders. Every day, scientists peer deeper into the cosmos, uncovering secrets that challenge our understanding and expand our horizons. From the faint echoes of the Big Bang to the mysterious forces shaping galaxies, the universe is a story still being written, with countless chapters yet to be discovered. Think of the discoveries that lie just beyond our reach. New telescopes, like the James Webb Space Telescope, are opening windows into the distant past, allowing us to glimpse the first stars and galaxies that ever formed. These tools are not just instruments of science, they are time machines, transporting us back to the dawn of creation. And as we look forward, we can only imagine what other marvels await us. Perhaps we will find evidence of life beyond Earth, or uncover the true nature of dark energy and dark matter. The possibilities are as vast as the universe itself. But the story of the universe is not just about the distant stars and galaxies. It is also about us. We are part of this cosmic narrative, born from the same stardust that formed the planets and stars. Our curiosity, our drive to explore, and our desire to understand are all threads woven into the fabric of this grand story. As we continue to explore the cosmos, we are not just observers, we are participants, shaping the story with every discovery we make. So, as you drift into sleep tonight, let your thoughts linger on the beauty and mystery of the universe. Picture the stars above, each one a reminder of the infinite possibilities that await us. The story of the cosmos is far from over, and with each passing day, we move closer to uncovering its secrets. Let this thought fill you with hope and wonder, knowing that the universe is not just a place of endless discovery. It is a journey, one that we are all a part of. And as you rest, may the gentle rhythm of the cosmos guide your dreams, reminding you that the story of the universe is still unfolding and the best is yet to come. As we wrap up our journey through the cosmos, let's take a moment to revisit the incredible story we've explored together. It all began with the Big Bang, a moment of unimaginable energy that set the stage for cosmic inflation, a rapid expansion that stretched the universe from a tiny speck to an unimaginable vastness in less than a blink of an eye. This expansion wasn't just about size. It was the foundation for everything we see today, from the tiniest quantum fluctuations to the grandest galaxies. We've traced the echoes of inflation in the cosmic microwave background, the faint afterglow of the Big Bang that still whispers to us across billions of years. We've marveled at how those tiny ripples in space-time grew into the galaxies, stars, and planets that fill the universe today, and we've pondered the mysteries that remain: dark energy, the multiverse, and the hidden dimensions that might lie just beyond our understanding. But the story doesn't end here. The universe is still expanding, still evolving, and still revealing its secrets. Every discovery we make, from the first light of ancient stars to the intricate web of galaxies, brings us closer to understanding our place in this vast cosmic tapestry. We are not just observers of this story, we are part of it, born from the same stardust that shaped the cosmos. So, as you close your eyes tonight, let your thoughts drift among the stars. Picture the universe as it was, as it is, and as it will be, a story of endless wonder, still unfolding with every passing moment. Let the gentle rhythm of the cosmos guide you into a peaceful sleep, filled with dreams of distant galaxies and infinite possibilities. The universe is vast, mysterious, and beautiful, and its story is one we are all a part of. Rest well, knowing that the wonders of the cosmos are always there, waiting to be discovered.